Welcome to Yaka Digital Network Videos. At the microscopic level, woven fabric is a blank canvas, a matrix of interlocking threads waiting to be manipulated. Compare that raw state to the vibrant reality of Ugandan textiles. From the kikoyi cloth worn in daily life to the patterned fabrics of school uniforms, these surfaces are highly organized displays of visual data. This tradition of surface design extends back to the physical texturing of raw bark cloth, where artisans modified the fibers themselves to create visual interest. Textile decoration is the deliberate process of transforming these plain, flat surfaces by introducing structured rhythm and balance. Beneath the colorful dyes and intricate shapes, this process relies entirely on exact underlying principles: geometry to place the pattern, printmaking physics to transfer the pigment, and chemical binding to lock it. Every complex design begins with a motif. This is a single mathematical unit, a distinct shape that serves as the foundation for repetition. To turn a motif into a pattern, you apply an arrangement, a layout rule governing how that shape multiplies across the plane. The first is grid layout. Here, motifs align strictly along fixed vertical and horizontal axes, creating a highly stable, formal repetition. The second is staggered layout. By offsetting every other row, the design breaks the vertical alignment, generating lateral movement and dynamic energy. The third is random layout. Free placement discards strict axes entirely, resulting in an organic, unpredictable composition. Controlling these mathematical motif arrangements is how designers establish rhythm and control the visual flow across any textile surface. Once the geometry is set, the pigment must be applied. Additive printmaking is the physical transfer of ink or dye onto the fabric, using a master matrix. In block printing, that matrix is a solid object. Using local materials like carved potatoes, foam, or scrap wood, the artist cuts away the negative space, leaving the motif raised. To ensure a successful transfer, the printing surface of the block must be scored. Creating shallow grooves increases the surface area, allowing the block to physically trap and hold the wet pigment before stamping. Stenciling reverses this logic. Instead of a raised stamp, the matrix is a flat sheet built entirely on negative space. The motif is cut out and removed. Modern material adaptations solve the problem of fragile paper stencils. By washing and repurposing durable hospital X-ray sheets, designers create rigid matrices that withstand repeated fluid exposure. A sponge is then used to dab the pigment. The physical pressure forces the dye through the voids in the stencil, depositing the exact shape onto the cloth below. Additive techniques succeed by physically building up the design, pressing thin layers of colored material directly onto the top layer of the fibers. Conversely, subtractive techniques, often called resist methods, operate on the scientific principle of repulsion. They block dye from entering the cloth. Physical resist, commonly known as tie-dye, utilizes structural tension. The designer folds the fabric tightly, compressing the material into a dense core. Binding those folds with strong twine physically crushes the internal fibers together. The pressure is so immense that liquid dye cannot penetrate the bound areas, resulting in crisp negative space when the fabric is untied. Chemical resist, like Batik, achieves the same goal using a thermal barrier instead of physical tension. A specialized tool deposits liquid wax onto the cloth. The melted beeswax seeps into the fibers and cools rapidly. This solidifies into an impermeable chemical wall that water-based dyes simply cannot cross. As the dyed fabric is handled, the stiff wax forms microscopic fractures. Dye seeps into these tiny fissures, creating the signature vein-like lines known as the Batik crackle. Interactive prompt. Which technique uses melted wax to block dye? A. Stenciling, B. Batik, or C. Block printing? The answer is B. Batik. Resist methods are strictly defensive. They create patterns by strategically protecting specific areas of the original fabric from external alteration. To move beyond simple two-color patterns, professional designers use overprinting or layering to build architectural depth onto the surface. Layering follows a strict procedural rule. Apply the lightest pigment first, let it dry, and progress sequentially to the darkest color. Because fabric dyes are translucent, light passes through them. When a wet dye overlaps a dried printed layer, The two colors optically mix, generating a distinct third color in the intersection zone, without requiring a separate printing step. This compounding complexity requires careful compositional balance. Designers must leave intentional rest zones, areas of unprinted fabric, so the overlapping sections remain distinct and readable. Even with perfect geometry, applying raw local pigments requires a binder to adhere the color to the fabric. Boiling cassava flour extracts its starches to create a viscous natural polymer. When mixed with raw dry pigment, this starch acts as a thickening agent, creating a suspension that grips the surface of the textile. Achieving professional complexity requires balancing both the optical mixing of translucent layers and the internal chemistry of these pigment binders. All of the structural layout and careful pigment application is useless if the design washes down the drain during its first cleaning. Water-based fabric paints require a chemical stabilization process known as the final fix to become permanent. For most garments, the catalyst for this chemical bond is extreme dry temperature, achieved through heat setting. Holding a dry iron over the printed motif for 3 to 5 minutes triggers a reaction. The heat bakes the pigment polymers, cross-linking them directly into the molecular structure of the cotton fibers. Finally, the fabric must undergo a mandatory curing time. The chemical bond needs a full 72 hours to fully cure and stabilize before the fabric can safely touch water. Without executing the proper heat setting and curing chemistry, all previous additive and subtractive design work is strictly temporary. Fabric decoration rests on 3 foundational pillars: calculating the geometry of motifs, transferring pigments through additive printmaking, and blocking color using subtractive resist methods. By applying these scientific principles, ordinary local materials, from carved root vegetables to repurposed medical films, can produce highly organized, complex textiles. You now have the exact technical steps needed to apply these layout rules and chemical processes to your own environment, whether designing a school bag or a large-scale surface pattern. You can watch more videos for all classes here and get all content at www.yaka.cc.